Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 5 on complex analysis. Today I'm going to teach you how to find the cube roots of unity. But before going to that topic, first let me explain you how to find the nth roots of unity. Students, suppose we have a relation like this, z to the power n equal to 1, where n is any positive integer. The solutions of this equation are called as the nth roots of unity. Now let us find the solution of this equation. Since z to the power n equal to 1, so therefore we can write z equal to 1 to the power 1 by n. Now let us express 1 in terms of exponential form. In one of my previous videos, I had already explained you how to write the exponential form of a complex number. So in our case, the complex number is 1. So this 1 can be written as 1 plus iota into 0. So from this, we can write alpha equal to tan inverse modulus of y by x. In our case, y equal to 0 and x equal to 1. So if we simplify this term, we will get alpha equal to 0. Again, we have noticed that this complex number is located at the first quadrant of the eigenplane. So therefore, principal argument of the complex number 1 will be equal to 0. If principal argument of the complex number 1 is 0, so therefore argument of the complex number 1 will be equal to twice m pi. Again, r will be equal to 1. So after finding r and theta, we can write 1 in terms of exponential form as e to the power iota twice m pi. Now let us replace 1 by e to the power iota twice m pi. So we can write e to the power iota twice m pi whole to the power 1 by n. Now let us simplify this term. After simplifying, we can write this term as e to the power iota twice m pi divided by n. Next, let us apply de Moivre's theorem. So according to de Moivre's theorem, we know that e to the power iota theta equal to cos theta plus iota sin theta. So after applying de Moivre's theorem, we can write z is equal to cos twice m pi divided by n plus iota sin twice m pi divided by n, where m can take these values 0, 1, 2, n minus 1. So this m equal to 1, 2, 3, n minus 1 will give us the n roots of unity. Okay? Now the next topic is finding cube roots of unity. For finding cube roots of unity, we have to solve this equation. That means z cube equal to 1. The procedure is same. What we need to do is we have to replace n by 3. So since z cube equal to 1, so therefore we can write z equal to 1 to the power 1 by 3. Now let us replace 1 by its exponential form. In my previous section, I had already mentioned you that this 1 can be written in exponential form as e to the power iota twice m pi. So if we simplify this term, then we will get e to the power iota twice m pi divided by 3. Now let us apply de Moivre's theorem. If we apply de Moivre's theorem, then we can write z as cos twice m pi divided by 3 plus iota sin twice m pi divided by 3. Here one important point is that this m can take values 0, 1 and 2 only. For m equal to 0, we will get first root. For m equal to 1, we will get second root, and for m equal to 2, we will get third root. Now let us find out those roots. So when m equal to 0, then we will get the first root. So z1 will be equal to cos 0 plus iota sin 0. Cos 0 plus iota sin 0. We know that cos 0 is 1 and sin 0 is 0. So therefore the first root will be equal to 1. Next, when m equal to 1, we will get the second root. Then z2 will be equal to cos twice pi divided by 3 plus iota sine twice pi divided by 3. We know that cos twice pi by 3 value is minus half and iota sine twice pi by 3 value is root 3 by 2. So iota root 3 divided by 2. If we simplify, then we will get minus 1 plus iota root 3 divided by 2. And this term is written as omega. Okay? Next, when we put m equal to 2, then we will get the third root. So when m equal to 2, then z3 will be equal to cos 4 pi by 3 plus iota sine 4 pi by 3. Again, we know that cos 4 pi by 3 value is minus half. Again, sine 4 pi by 3 value is minus root 3 by 2. Iota root 3 divided by 2. So if we simplify, then we will get minus 1 minus iota root 3 divided by 2. And this term can be written as omega square. So we have seen that the cube roots of unity are 1, omega and omega square. 1, omega and omega square, where the value of omega is minus 1 plus iota root 3 divided by 2 and the value of omega square is minus 1 minus iota root 3 divided by 2. Some important relations. The sum of cube roots of unity is always 0. That means 1 plus omega square is always 0. Second property is the product of cube roots of unity is always 1. That means 1 into omega square. That means omega cube is equal to 1. 1 into omega square. That means omega cube is always 1. So this is all about today's video, and it is the end of module number 1. In my upcoming lectures, I'll be explaining the contents of module number 2. Those contents are extremely important, not only for your B.Sc program but also for your various competitive examinations like CSIR NET, GATE, JAM, etc. Okay?